Okay, welcome. Welcome to the panel on the data center sustainability. So thank you so much for taking time to attend this panel. My name is Alessia Dimit. I'm OCP Future Technology Symposium Chair, co-lead for the OCP Startups and EMEA Liaison. So I have a pleasure to have the invited keynote panelist speakers today, and also the pleasure to have you in the audience. And we are going to talk about the challenges and opportunities around the data center sustainability. As you might have heard from the previous presentation in this track and on the open hardware, the data center sustainability questions have become critical, and we need to take actions to address those questions and also come up with solutions. So I have a pleasure to have the speakers, and I'm going to present the speakers. And after that, my dear guest, I will start by presenting each of you. Then I will ask you if I missed something and if you would like to add anything. And I will follow up with the icebreaker short questions. So please prepare your answers. So I would like to start with Deborah Andrews, who is a professor of design for sustainability and circularity at London South Bank University. So Deborah has extensive experience in sustainability design and manufacturing and the circular economy. She has published more than 60 papers, and he was academic lead for CEDASI, which is one of the largest European projects in the circular economy. She has also won the best paper in the Future Technology Symposium last year at the Global Summit. Deborah, did I miss something?
Nope.
Okay. My question to you is the following. You're an active participant in the open source industry events and also academic industry type of partnerships. So tell us about why circular economy projects made a real impact on the industrial partner. Maybe you can tell about your past experience.
Okay. Hello, everyone. Very select audience here. Nice to see you. So I'd like to think that I'm an ambassador for circularity in the data center industry. I've worked with the industry for a number of years, and one of the things that I found was there was a huge concentration on operational energy efficiency and very, very little, if any, consideration about the impact of hardware itself. So the CEDASI project, which is an acronym for Circular Economy for the Data Center Industry, it was set up to try and address that gap. And it was a pan-European project, and I collaborated with Astrid from TechBuyer, amongst other stakeholders, and we looked at the whole life cycle. Well, we looked at all life cycle stages, so right from design through to extending product life, if you like, midlife, and then what happens to equipment at end of life, recycling and materials reclamation. And it's incredibly important because a lot of the work that we did, we found out that the embodied impact of equipment is actually an awful lot higher than the general assumption. That if you are just looking at carbon, it doesn't include thousands of impacts and or inputs and outputs and impacts. You need to look at all of those things in addition to carbon to really understand the full impact of any equipment, and in particular electronics, which has an incredibly high embodied impact, partly to do with the materials mining processes, but the manufacture, etc. as well, the lifespan, all of those things contribute to very high impact. And basically, if we don't start reconsidering the way in which we design stuff to make it more easy to extend product life and recycle at end of life, we're going to have a huge problem, because most of the resources that are critical to data center equipment are limited. And at the moment, at end of life, we're just chucking them in holes in the ground. We're not repurposing those materials. So we really need to take a whole systems and whole life approach to the challenge of data center equipment. And it's becoming increasingly important in line with growth of AI, which not only is going to increase energy demand exponentially, but also the demand for equipment. So yeah, we need a big rethink.
Thank you so much. So our next panelist is Astrid Wein. So she's the head of public sector and sustainability at TechBuyer. So TechBuyer specializes in product life expectancy and enterprise IT hardware. She's the global specialist in the provision of sustainable IT solutions, and she's a board member of the Free ICT Europe and works with the European Commission on secondary market for IT hardware, software, and maintenance. She's also the co-author of 6 academic papers on circular economy and efficient energy efficiency in the IT sector. Also, we know that because of Astrid's commitment to sustainability, in 2020, TechBuyer won the Circularity Economy Organization of the Year award, and in 2021, the Most Sustainable Organization of the Year. So, take into account all your impressive accomplishments. Astrid, what makes you feel excited and motivated in your everyday job at TechBuyer?
In all honesty, events like this and how open the sector is to looking at better ways of doing things and working with companies large and small to that end. I've got one of the research team in the room with me who's amazing. We have a lab where we conduct experiments on hardware for energy efficiency and looking at the effect of like temperature and bigger environmental impacts there. The fact that a company of our size is welcomed and engaged with and talked to by some quite large players, I think is really, really hopeful because it shows a massive commitment of the sector to work on areas that they don't already understand. That's what really excites me. It's kind of like the commitment and the passion.
Thank you. So our next speaker is Simon Allen. So Simon is data center consultant at Cato Digital. More than 20 years, he has more than 20 years in data center industry experience, leading international teams of development in large data center infrastructures. In 2011, he founded the UK Data Center Interest Group with a goal to facilitate the sharing among the data center operators, designers, constructors, and build consultants. In 2018, he was an executive director of Infrastructure Masons, global nonprofit association with industry leaders that address complex problems and challenges. And since 2022, Simon is with Cato Digital, deploying circular economy OCP open hardware solutions that dramatically reduce carbon emission. So my icebreaker question for you is, you, in your career, you managed to bring together the people from different processes and sides of the data center industry. So what are some of the valuable lessons you learned that can help us facilitate those conversations when we're talking about the data center sustainability?
Thank you, Lisa. It's great to be here. Very nice to meet Deborah finally. And we met before Astrid, I think. I've known Mark for many years now. I think one thing I can bring to the table is the ability to join the dots. I've been in the industry a long time. I know a lot of people, basically. I understand the problems. I like to echo what Deborah said, that with AI, the demand for not just energy, but equipment is just going to skyrocket. And we need to find a sustainable solution. With the iMasons, I was working with the leadership of some of the biggest IT organizations in the world. A lot of them, it's sad to say, are very much involved in greenwashing, and that's something that's got to be addressed. But despite that, a lot of people in our industry are very passionate about sustainability and very genuine. David just talked about a guy called Christian Bellady from Microsoft before. He's one of the most passionate people I know. The founder of the iMasons and the CEO of Cato Digital, where I work, he is also very genuine and very committed to sustainability. But we've got to work together. We've got to work with people like Astrid, who understand and have got the connections to the European organisations, and people like Deborah, who's got very clear vision in terms of what needs to be done. And I think by working together, We were just having a conversation before. If there's sufficient people and we get the weight of the industry behind us who are all motivated to do the right thing, we can do it. It just takes that weight of people, that commitment, and lack of bullshit and greenwashing, whatever you want to call it, to actually get things done. So that's how I like to think I might be able to bring value, just by connecting the dots and bringing these people together and focused on the end result.
Thank you. It looks like bringing different voices to the same table and ability to connect the dots could help us facilitate those conversations. And our next speaker is Mark Dancy. So Mark is OCP Ready Facilities Lead at the Open Compute Project Foundation. So Mark leads and supports diverse OCP projects, but specifically those who are focused on OCP Ready and OCP facilities and open hardware. And Mark is a strong believer in the openness, and openness always wins in the end. Mark, what do you think? What are the most challenging when you work with engineers and decision makers in the open source hardware community?
I think one of the biggest challenges is transparency. It's something that I think has quite a big degree influence on sustainability. Unless we can start to compare say data centers with data centers, apples with apples. Everyone is measuring, say, sustainability metrics in the same way. We're never going to allow a user to be able to select the right types of facilities to host their equipment. And therefore, we're not going to be able to improve the industry overall. So openness, as Liz mentioned, openness wins in the end. That's what we're doing in OCP. We're trying to create open collaboration environments, bringing together the likes of Astrid and Deborah and Simon together. And that's what OCP is about. It's all about bringing together people, like-minded people. I'm on the same wavelength as these other three people near me. I'm involved with OCP because I feel it's the way that I'm going to be able to reduce the impact on the environment through the use of data centers. So,
Thank you,
This
Mark.
is the best place for it.
Yeah. So now, when we know a little bit more information about our fascinating speakers, I would like to suggest that we move forward in conversation with different questions, and also we will take some questions at the end of this session. So please prepare your questions for the Q&A session. So Deborah, can you explain about the Circular Data Center Compass digital tool that you have created and you work on and at the London South Bank University? And what's the intent to assess and help improve data center sustainability? How this tool can help?
Okay, so the tool, the Compass, it was one of the key outputs from the Sadassi project, and it wasn't just London South Bank that developed it. It was an absolutely 101% collaborative effort by all the partners, which was great because we brought together people with expertise from all the different subsectors that comprise the data center industry. And that was actually one of our USPs. Lots of people said they hadn't talked to, X and Y in different sectors before, so there was a lot of mutual learning. So the tool is basically, it was developed to help anybody and everybody who is interested in sustainability in the sector to make informed decisions. So you might be an operator thinking about changing equipment. Are you going to upgrade? Are you going to buy new? There's a lot of pressure from OEMs, as we know, to buy new. But actually, the purchase of refurbished, re-engineered, whatever equipment can serve your means very well. So our tool dealt with that sort of midlife stage. And it's a free online tool. And that element allows you as a user to swap components, to reconfigure servers to meet your requirements. And you can then compare the environmental impact of an original server, a new server, and a refurbished server. So you look at the environmental impact, but we've gone beyond that. We've also allowed you to look at the social impact, which in the electronics sector is massive because an awful lot of the materials are mined in very unfavourable and hazardous conditions. And also we've included cost. So those are the 3 pillars of sustainability. And a sort of added bonus, if you like, criticality. What is the level of criticality of the materials in the product that you're using? And that is something that is going to become more and more important. It's something that criticality is now sort of being highlighted across the EU and I guess the US as well. So we've got the midlife bit of the tool. We've also got the end bit of the tool. When you're retiring equipment, are you going to process it through a normal recycling route where only 4 metals are reclaimed, copper, aluminium, gold, and anything with iron in it, so steel? Or are you going to send it to a more sophisticated recycling system? Or you shouldn't send it to landfill, but we include that as a sort of benchmarks to highlight the benefits of recycling. Or is refurbishment your preferred environmental, social, economic choice? And then the last bit of the tool, the Eco-Design Evaluator, allows designers to make decisions that facilitate circularity. So we look at things like reducing embodied materials, designing modular systems, removing some of the other barriers to circularity as well. But the good thing about that, as with the other tools, is that as you're going along, you can get visual feedback about the level of circularity of the decisions that you as a designer would make. So we've got a huge problem. A lot of the sort of sustainability-related activity in the data center industry at the moment is to do with equipment that's already in circulation. It's reactive. How can we change things slightly to extend life or to improve recyclability? What we really need to do is go back to fundamentals and change the way in which products are designed as well to facilitate better practice at mid and end of life of products. And only by doing that can we really achieve a circular economy. So please do look. I'm a little bit disorganized, I apologize, I haven't got any business cards, but look online for the Cetacea project and you'll find a link there to the Circular Data Center Compass. And all we ask you to do, it's free to use, so all we ask you to do is to sign up so that we can track who's actually using it. And hopefully by, investigating what's on offer there, you can improve your own business practice.
Thank you. So to continue the conversation around the same measurements and metrics, I would like to move to, with the next question to Astrid. So Astrid, you did some studies and I believe also practical experience in measurement of data center footprint. You also co-authored the paper on Is IT a False Economy? So can you tell us what are some of the key findings from this project and what are some of the metrics that we should be aware of?
Big question. The paper was called Is Hot IT a False Economy? And if you want to know exactly what the moving parts of that are, I suggest you speak to Kat Burdett, who's in the front row, the lady with red hair there, because she carried out all the testing. What that paper was about was looking at what we're not seeing with data center sustainability metrics in abstract. That's what we were doing. And the paper started doing that by looking at trade-offs in IT efficiency as you raise temperatures, which has been written about before, and then as you add in cooling, and what the trade-offs are. If you reduce the energy in the cooling, what happens to the fans, what happens to the degraded IT efficiency as a result of different temperatures in the IT hardware. It was interesting because then the team took a model data center that was based in London and said, but our highest growth of data centers is outside the traditional areas. Our highest growth curve is in the developing world. So what happens if we take the ASHRAE envelopes and we say, well, this is what works best in London, but how about if you've got high humidity? How about if you've got high temperature? Which cooling architecture will work in that environment? And then what's your knock-on effect? So you've got this dynamic system of a set of moving parts, I think is the simplest way to describe it, where if this has an effect on this, what's your kind of algorithm there? And then as you transplant that around the world, what's the effect of the external environment? It's an interesting paper. I recommend you read it. It may not be your area. What we're really trying to flag up is there's a pile of stuff when it comes to data center efficiency that is not measured because you're looking at static measures. You're looking at ratios like PUE and even CUE and ITSSV, and all the other metrics that we're using are basically static measures. They don't look at the system. And we need to look at the system, and we need to look at it as a machine if we're going to optimize it. And we further need to think about sustainability in three aspects. We need to think about use phase sustainability, material sustainability, which is kind of where we're kind of getting into. But we also need to think about the why, and we've got a gentleman here who's talking about green coding earlier on. He'll tell you all about the why. What is this doing? What's it generating? You know, what is the benefit of what we're doing there? And when you look at it as a whole systems approach and then take your relationship with the data center and the outside environment, then you're getting somewhere, which is kind of where heat reuse comes in. So that paper was the beginnings of that. It was the beginnings of looking at those moving parts and flagging the fact that we may want to explore that further. And I think I've talked enough, so.
Yes. Okay, so moving forward with a question to Simon. So Simon, Cato Digital is on a mission to build the most sustainable bare metal cloud in the world by offering low-cost, low-carbon compute in all the right places. So can you share with our audience and with me, how can you achieve this ambitious goal?
Sure. Yeah, indeed. Cato is building the world's most sustainable cloud. A little background about Cato. It started life as a company called Virtual Power Systems. Most data centers are built with additional capacity, spare capacity, just for resiliency or redundancy, which kind of makes sense for a business-critical environment. But that energy just isn't being used. It's stranded, it's wasted. So Virtual Power Systems literally virtualized the power and was able to exploit that stranded or wasted capacity for other compute. But more importantly and more relevantly to this discussion, Cato also uses recycled OCP hardware, mainly from the hyperscalers, people such as Meta. Typically, a data center will refresh its IT 10 times in the life of a data center. I hear different numbers, but for between 3 and 5 million servers are going to be replaced in the next 2 or 3 years. It's a huge number. And if we can extend the life of the servers, it goes back to what Deborah was saying, then that's going to have a significant impact on the carbon, especially if we can add to that OCP hardware to extend its life. For example, we're adding NVMe drives, which is like super duper flash memory, to the V100s, the GPUs, and that could add an extra 4 or 5 years to the life of the server. Probably the most frustrating thing for Cato, we're only a startup, we pivoted to Cato when we realized that data centers are just too conservative to start leveraging this wasted power themselves. They've got these big 5-9 customers that they don't want to upset, and they think emotionally that if their big customers, such as the banks, realized they were using this spare capacity for something else, they might get a bit nervous and take the business elsewhere. So sadly, we didn't get any traction with this virtualization of power. So we pivoted to Cato Digital, and we thought we'd be our own customers. So we started recycling this OCP kit, refreshing it, validating it, and putting it into OCP racks. We've now got 5 locations, 2 on the West Coast, 2 on the East Coast of the States, and 1 in Africa. So we've proved the model. We work with partners such as Kudo Compute, who are a UK company, and they're a platform so people can just, like a marketplace really, if people want bare metal. For those of you not familiar with bare metal, companies, instead of buying their own compute, they can rent compute by the hour, by the month, by the week. It just takes a risk out. And of course, it's got a great sustainability story as well. So Cato Digital's vision is to have 1 million servers in 1,000 locations. It's still early days. We've only got 5, but we're expanding quickly. Thank you.
Thank you.
Sure, next.
So Simon, you mentioned that Cato Digital is using the OCP hardware.
Yeah.
Mark, now, for those people who were not able to attend our OCP talk earlier today, can you remind what is OCP hardware, open source hardware, why those designs are sustainable? And the next question would be how OCP-ready facility that has the OCP equipment deals with the sustainability advantages for hyperscales and enterprise on those facilities.
Okay, so I'll start with number one question about what is OCP hardware. Well, so just to be clear, OCP doesn't make anything, but we have a platform to enable manufacturers, end users to contribute designs in an open source fashion. So in a similar way that works in the open source software world. So we're a platform to allow this contribution, and the equipment, and for an example, you may have seen a Tioga Pass server that was on our table, but that was contributed by Meta. They contributed all of the design files, all the information that you would need to manufacture that equipment yourself. The only thing that you would have to buy would be the silicon, because we have a sort of situation in OCP where we're working with companies that don't want to completely share their IP. So we work in conjunction with the IP that the companies have, but they also collaborate their knowledge and experience to work on maybe the module that maybe the silicon that's going to go into. So the common sort of factor, like the rack or the circuit board, that is open source contributed, and then companies can add their own secret sauce to those base sort of specifications. The equipment, certainly as an example, that Tioga Pass server is inherently sustainable. So OCP was started back in 2010. That equipment was probably around sort of a few years later. So it was already a sustainable design. It uses the minimum amount of plastic, the minimum amount of metal. There's no gratuitous differentiation that many of the OEM server manufacturers use. You know, putting bezels on the front, putting their logo on the front. There's none of that on OCP contributed designs, because it's all about maximizing the airflow, and the airflow would be constricted by having a bezel on the front of the server. So that was all taken away. It's a minimum design, but it functions, and is designed to support the circular economy that Deborah was describing. It's built in a modular way. It can be broken down, and it can have an extended life, because you could use maybe an open source firmware within the equipment. You're not dictated to by an OEM manufacturer that's saying that's end of life, we're not going to support it anymore. With an open piece of recognized hardware contributed to OCP, that can be used as long as you want to, because you're supporting it. You're not expecting an OEM to support it. So that's an example of the sustainability angles and being able to extend its life. And the equipment that Cato are deploying would be absolutely suitable to be deployed in an OCP-ready facility. So just to quickly describe what an OCP-ready facility is, it's been recognised by the OCP-ready program and by the OCP Foundation that it meets the fundamental facility requirements of the physical infrastructure and base building requirements and the security needs and specifications of a data center. And within the OCP community, we came together collaboratively between manufacturers and designers and architects to come together to create a checklist which would allow a data center to assess itself whether it meets the requirements for hosting OCP recognized hardware like the equipment that Cato supply. So we create an assessment process which helps users identify which data centers are optimized for OCP recognized hardware and racks, and therefore they're going to work the most efficiently, in the most efficient way, be hosted in a sustainable way, and this is being now deployed and used. This program is being used by the hyperscale community to identify data centers that they can use in a sustainable way to build out their cloud region. So quite some collaboration has gone on since the inception of OCP back in 2010. Yeah, we've got a bright, exciting future and open to collaboration from all.
Thank you, Mark. So we do have around 10 minutes before we need to wrap up, and I do have more questions for you. But before I take those questions, I would like to ask, do we have any questions from the audience? And yes, we do. Can we have the microphone? No?
Yeah, thank you for your answers. Those were very interesting. I actually have questions for all four of you. And it's just one simple question, but what do you think is the biggest roadblock in improving the sustainability of the data center industry at the moment? Should we start on the right?
Who would like to take this question?
Sure. That's a big question, of course. I think transparency is probably the single biggest thing we need to achieve. And that's been a challenge so far. People have got, I wouldn't say ulterior motives, but people are driven by commercial factors. And I think that's got to end. There's a whole raft of laws and regulations coming into place, certainly in Europe now. They're going to have a big impact, I think. For me, personally, I think one of the biggest challenges, as we were discussing before, is having a methodology to depreciate carbon, to promote the circular economy. Because at the moment, I don't know if anybody's had the chance to read Astrid's article. It was referenced in Data Center Dynamics just yesterday. You could be penalised for actually buying recycled kit because you're adopting all the carbon that's associated with that kit and potentially carbon involved in recycling it. So people could be disincentivised to actually buy second-hand kit, which is an appalling and untenable situation if we're going to develop a sustainable solution, especially with the growth in demand. So I think carbon accounting and transparency are probably the two things that I think are most important.
I think one of the things that we need to agree on within the data center industry is on the metrics that we should be measuring and get some agreement across all of the players that these are the ones we must measure, and we should measure them in the same way. And at the moment, we've got a situation that's been come along for many years. We've only got one real metric that everyone recognises, which is PUE, which is power usage effectiveness. But it's not really a sustainability metric. It can be gamed. And certainly the EU have taken some leadership in trying to create a framework for data centres to report on not only the consumption of the equipment, consumption of power, for instance, but also what the users are hosting in those data centers as well. We've never had a situation before where the users will need to report to the data centers, who will then report to a regulatory body. So this sort of, backs up what Simon was saying about transparency. We need transparency, but we do need to agree on what everyone should be transparent about, so that we can compare services between each other around sustainability, which we don't have that. We don't easily allow our users to understand how to compare. So I think that's a bit of a blockage at the moment.
On a slightly different tack, I get, we go to events like Data Center World, the big trade events and so forth. And yes, there are an enormous number of people who are incredibly positive about sustainability in the industry and really want to make change. And it's really disheartening when other people come along and say, nah, nobody will ever do that. I really hope those people are in the minority, whether they're afraid of change or what, I'm not quite sure. But another slightly different point, in terms of sustainability, and I've mentioned recycling, and I don't mean reuse as in but recycling at end of life. We've got a huge problem. There is not an adequate infrastructure for recycling and reclaiming materials. It just does not exist. There is evidence of really good research, people developing new technologies to reclaim a lot of the materials that are currently not reclaimed. But we need a lot more sort of, push to encourage that and to support the economics. And it's a bit of a chicken and egg. We need more throughput through legitimate, really good recycling facilities to develop critical mass to mean that the processes are economically viable. And we can't get that until we've got the infrastructure developed. So, we need this push and pull on that front. So it's great talking about sustainability, but we really need to improve the infrastructure throughout the whole value chain to make it happen.
I agree with everything that everybody else has already said. But I'm last, so I have to say something different. I think one of the biggest blockers to change is the lack of understanding in our consumers. I think with other industries are forced to change by buying power and by what their customers are asking them to do. And I think that there's not enough awareness in the general populace that data has a material and a carbon cost, that it is not free, and that the materials that supply the production of data are going to run out. Not just the critical raw materials, which is better publicised than other things, but water, land, the natural capital that feeds our systems is running out. And if you look at the planetary boundaries, we're exceeding 6 of those. And climate is the least of our worries when it comes to that. We are in a big problem. And I think that if we as a society and as a community understand that, and understand that, yes, technology is a pathway towards a more sustainable world and a better way of doing things, but it's going to have a cost. And we need to think about how we're spending our data and how we're spending our technology, then that thought change will drive behaviour change within the industry, because we'll have to work together to make that happen.
Thank you. And I know that we have another questions, right?
Thank you. Question about the legacy software and legacy hardware. What do you think is conjunction of open source software and open source hardware allow to achieve better hardware utilization? I mean, hardware utilization efficiency. Can we achieve more than with legacy software and legacy hardware? Is it allowed to achieve better?
Open source?
Yes, open source software in conjunction with open source hardware. Can we achieve better hardware utilization?
I think yes, is my view on this. And I'm aware that there's somebody in that row there that can probably answer this better than I can. Taking it from the outside, which is how I'm always going to look at it, because this is not how I grew up. I didn't grow up in the tech industry. If you've got a system which enables people, I always think of it as a car engine. If you've got a system that enables people to lift the hood and rework their engine, and you've got a community of people educating each other on how to upgrade that engine, and you're not having the power taken out of your hands by somebody switching off that system or making that hardware obsolete, because you've got behavioural ownership of that hardware, then you have a chance of extending the product life, and you have a chance of making systems work for you, and you have a chance of saying, you know what, I don't need that Ferrari that you're selling me. I can do quite well with the Mini, and I can keep my Mini, and I can just go to the chip shop every day. I'm happy. Leave me alone. If you've got an open source community that's supporting that knowledge and that confidence, then you're a lot better along the way of that. And I'll leave it to my esteemed co-panelists too.
Anything to add?
I've got nothing.
Or do we have maybe another question? Yes.
Ladies first.
That's really kind. Thank you. Great discussion. Thank you so much for all your insight. I wanted to ask a question about the elephant in the room, which is around AI and how that is driving massive increases in the capacity for data centers. You were talking about it earlier. I think you said every year it was 10 times, every generation was 10 times more power. And it was a very open question, really. I just wondered, from your perspectives, how you see that challenge. And would you just turn all AI off? It's a deliberately provocative question, but...
You know, I've got the mic, so I'll start answering that if you don't mind. First off, it's nice to know to keep you happy, you just need to get to the chip shop, Astrid. Easily pleased. I think Astrid made a really important point before. We need to figure out what we're going to use AI for. And the potential of AI is unquestionable. It can make dramatic improvements for all of humanity. But it can also help make cats look prettier on TikTok and stuff like that. It's all about educating the users in terms of what the real value of AI is and should be, and the costs involved of not using technology gifts like AI or misusing it for the wrong purposes. There are recycled solutions for AI as well. We've all heard the horror stories about the latest GPUs not being available, the H100s. That's going to be the case for the next 18, 24 months as a handful of companies just suck up all the NVIDIA production. But older GPUs can do the job just as well. The V100s, for example, that may be 3 or 4 years old, coming out of people like Meta now, they're perfectly good for most machine learning type operations. So again, recycling, repurposing, refreshing, circular economy is a solution, but it's not the full solution. I think public education and just being a bit more critical in terms of what AI applications are developed could be part of the solution.
I think it was quite an interesting point made this morning by the professor, I think it was, of Cambridge University, and he was saying about where we need small actors involved in iterations and developing AI, and that the big tech companies don't actually know. In fact, they haven't got the solution fixed yet. They don't know how to. They don't know how the infrastructure is going to evolve. They do need a community around them to support them in the journey towards creating the infrastructure to support the applications. As Lesia mentioned earlier, other talk about the hardware hasn't caught up with the AI software development. I had someone come to our table earlier saying, we haven't got enough HPC resources to do some medical calculations around genomic sequencing, I think it was. So it's important that within OCP, which is the place where all the development really is going on around hardware, open source hardware development at scale for AI, that community really sort of innovates, but we need all of these sort of smaller actors all doing their piece to actually make it happen. We're open source hardware, open source software working together to create the infrastructure to allow these applications to happen. And I think AI is good. I'm looking forward to having a robot to help me when I'm 99. So I want it to happen, and also drive me around as well. To the chip shop. To the chip shop. Well, yeah, somewhere like that. But yeah, I think it's an absolute need.
Yeah. Anything to add, or would you like to take the next questions?
Well, all I was going to say is I have a completely schizophrenic response to AI. I mean, the brilliance that, medical, the applications, medical, science, etc., is gobsmacking. But as an educator, it's turning into a bit of a nightmare when you get submissions that have been ChatGPT'd from students. That's really, really tricky. But I had a very interesting comment from one of my colleagues the other day who he teaches CAD and graphics and so forth, and he said the introduction of Photoshop, everybody at the time thought it was going to completely get rid of the graphics industry and everybody will be able to be a graphic designer, and we know that hasn't happened. So maybe the same will be true for AI. At the moment, where it's so nascent, let's not be too negative about it and keep our fingers crossed.
I am hopeful about AI because I think that it can possibly do some really useful things. Kat and Steve, keep going on about Kat, were telling me about AI design for chips and how it had taken account of the silicon in the chip, which is something that the human brain can't do because we can't factor that many data points into our thinking, but AI can do it. And it can design a chip that works, which when the engineers take out some of the connections, it doesn't work anymore because they don't understand the materials the same way that you can make AI understand the materials. That example leads you to think that AI can design systems that are an awful lot more evolved and an awful lot more efficient at societal level than we can currently do. So David works on heat reuse, combined heat and power. That's taking data centers as heat production and then integrating that into society. Imagine if we gave AI that problem and say, redesign our cities. Maybe it will find a load of materials and energy savings that will be really helpful to us. I think there's, quite good evidence that it might be able to do that.
Thank you. So unfortunately, it's time for us to wrap up this conversation and to conclude this discussion, very interesting discussion. I would like to suggest to you in 30 minutes, what's your call for action for our audience and guests? What's your call for action? Call to action. What do you invite?
Call to action. Oh, okay. That's a great question. I would, again, echo what Astrid said earlier. Maybe we should start thinking more about what we're using technology for. Simple as that.
Yeah, I think we should be looking to encourage our suppliers to be more transparent about their sustainability and about their metrics, and to ask the difficult questions before going ahead and buying services. So I think we need to demand from the service providers and big tech to be more transparent, and therefore, we can use more sustainable services, which will then help. Us save the planet and save humanity. That's what we've got to achieve.
That's a nice takeaway.
A hard one to follow, Mark. Okay, well, once we've saved humanity, so I think we also need to educate end users, because an awful lot of... There's this fantastic poster in Waterloo Station at the moment, which is some kind of service provider. I can't remember who, but there are pictures of the cloud and little things pinging up to clouds. And that is public perception of, what data is. It just goes into the sky and something magic happens. And I think we really, really do need to educate end users way beyond, operators and industry stakeholders. Every time you look at pictures of a kitten or your grandpa or whatever, what is the actual impact of that? So, yeah.
Yeah. Pretty much the same, and also educate people in how to use technology as a tool and not to become a battery for technological systems. I think too often people are encouraged to think that because they're using an app, they're being technologically savvy. They're not. They're being controlled by the machine, and it should be the other way around. So encourage people to engage in technology, understand some of the concepts, and engage with each other as well.
Thank you so much. So our panel is coming to the end. I would like to thank you, our guest speakers, and also you for attending and taking time to attend this panel. If you're interested to continue the conversation, please reach out to our wonderful speakers, or if you would like to continue about the OCP. And I'll see you at the next event. Thank you.